Hi all, let's do some more C++. We're going to do number 11, and it's just one program. It shows you how to use a class, a CLASS. It's kind of early to go over this type of thing, but I thought we'd go over it because you might be flipping through books or videos and this class term might keep popping up, so you might be curious what it is. So the program itself really isn't that hard, but getting the concept of how a class works, that might be the tough part. It might take you a few days, a week or so to be able to grasp the concept of a class. So if I lose you here, don't worry about it. After this video, we'll go back to our regular videos that we've been working on. But it's really not that hard. So let's run it first and see what it does. So I'll take this number 11 folder, put it on C:. I'm going to grab a shortcut to it. Let's start up the DOS prompt. We'll go to C:. Now we'll go into the CPP folder. Now we'll go into number 11 folder, and our program is in the class 1, so we'll CD into class 1. We'll run the compiler, then we'll run the program. You can see all it does is prints out C is 7. So that line comes from here. C is 7. So we just add up these two numbers, put the total here, and print it out. But we're using a class to do the math. So most of this should make sense to you. There might be a few lines that are new. So let's pick through this. iostream.h, you should understand that. Here's our class. We create a class, we name it. You can name them just about anything. I like to name things with a my, so then you know it's not part of the programming language. So we named it my adding machine. We create two integers, a and b, and they're private. Private meaning they're only available inside the class. So here's private, public. So the function is public. This is our function header. This tells the class, hey, we have a function named add stuff. It takes two integers and returns an integer. So this starts it, this stops it. This is the class. This is kind of odd here. This is the way they do it in C++. If we take this out of here, that should look normal. to you. It's just a function called add stuff. Takes 2 inch. Create a total, add the two numbers together, put the total in here, return total. The return value comes back here. And then this, all this says is the add stuff function is a member of the myAddingMachine class. This is kind of odd here, but that's how it's done. You just give it the name of the class and put the 2 colons. Okay, and then down here we have our main. So the program starts at main. This is just one of them new mains that we talked about earlier. Main function returns int to the operating system. That would be this guy here. Return 0. 0 goes back to the operating system just to tell it that, hey, this program ended with no errors. So we create an integer named C. And then these 2 lines will be the tricky lines. Here we create a variable of the type my class, myAddingMachine. And we name it A. This is the same as like when we went integer A, integer C, except we're creating variable to hold an instance of the class. Okay, so here we create an integer and name it C, and then we create our class and name it A. Okay, so that is this guy here. And then on A, we call the add stuff function. The A is actually an instance of the myAddingMachine class. So on the instance of the myAddingMachine class, we call the add stuff function, send it 2 numbers just like we normally would. Add stuff does what it's gonna do, adds up those 2 numbers, returns a 7. When add stuff returns, it puts a 7 in here. Okay, so there's some pretty heavy duty concepts going on here. So we have a class. This is our class. Think of a class as just some typing inside of a notepad file. Okay, it's just a class. Here's our class. Here's the code that goes with the class. When we do this, we're saying, hey, use my adding machine class and create an instance of it. An instance of the my adding machine class. When this turns on this class, it runs it in memory. It's running in RAM. And then this guy is a handle to this class. So we can get to it, right? It's just not floating around in there. We have to be able to use it. It's a handle to it. We instantiate the class. This class here, when we turn it on, we instantiate. That's this. We say, take the my adding machine class and instantiate it, make an instance of the class, and make the handle A. Just like we did this type of thing here, except we're using the class here. Now, when that instance, that's a fancy word, instance, we instantiate the class file to create an object. O-B-J-E-C-T. The object is running in RAM. The object of the class file. We instantiate the class file to create an object running in RAM. An instance of the class file is an object running in RAM. So I don't know any easier way to say that type of thing. So that's why I said it might take a week or so to really grasp what's going on. So we have a class file. When we do this guy, we create an object of the class file running in RAM. We instantiate the class file. This is our handle to the object. And now we say, hey, on the A object, call the add stuff function, send it these two numbers. Add stuff does what it's going to do. This should be easy. We went over this type of thing many times in the previous videos. Return 7. When add stuff returns, it puts a 7 in here, and then it does the printout. So, like I said, it might be a little early for this type of thing. So if I lost you there, don't worry about it. I just wanted to give you an idea of what a class file is. It's just a fancy way to store a function. You put a function inside of a class. Why would you want to do this type of thing? Let's say I'm working somewhere and I create a big class file that does something, that starts up an engine or something, right? And the guy next to me says, hey, I gotta write a function that starts the engine. And you can go, hey, I wrote one last week. I'll give you my class file. And then all you have to do is give him your class file and he can use it inside his programs. He doesn't have to start from scratch and create the whole thing. It's just a fancy way to encapsulate your code. it makes it easier. You don't have to rewrite the same thing over and over again. The old-fashioned way of programming in like C, just regular C, what you would do is just cut and paste. You might be cut and pasting paragraphs of code or pages of code, or these days you put everything inside of a class, and you can just give them that text file and tell them how to use it. Say, hey, send it to integers, and the class will know what to do. Of course, you have to tell them how to use it, right? Send 2 integers, and you're going to get an integer back. So there's definitely a lot more to this, how you create a class, how you destroy a class. But for now, I wouldn't worry about it. We've got a long way to go before we get to the details with this stuff. I just wanted to give you a general idea of what a class is. This one is just a class in Java. You might have buddies taking a Java class. It's basically the same thing, but you can see the code's just a little different. You see their main function is basically the same thing. They just put all this stuff in front of it. This is just the stuff that's coming from the command line. We haven't gone over this yet. When you run your program from the command line, you can set it up to where like these 2 numbers would come into here. So that's what this stuff is for. But most of the time you don't even use that, because programs don't run from the command line anymore. They run from a GUI, a GUI like like these. This is running a program from a GUI. You're not doing it off your DOS prompt. And you can see here it's basically the same thing. Create an integer, do some math. That line is commented out, and here we just do the math right on the line. And then instead of using cout, they do a print line. So most programming languages do look the same. You can see how that's real similar to C++. But usually the input and output is what's different. Cout, cin, how do we get stuff into the program and out? That's what's going to be different. Here's a class in Java. A common phrase in Java is everything's inside of a class. That's what they're doing here. This starts the class, this ends the class. Everything is inside the class. Where in our C++, main was outside of the class. Okay? So if I lost you there, don't worry about it. We'll go back to our other programs next video. Before we quit this time, I wanted to go over this. These are the important words inside of C++. Inside every language, there's a set of important words. and those are called keywords. Whenever I learn a new language, one of the first things I look for are the keywords. What are the keywords in C++? What are the Java keywords? What are the Ruby keywords? Usually it's the same stuff, integers and stuff like that. As I was putting together this list, flipping through websites and books, practically every list I saw was different. Usually the list is pretty stable. It doesn't change over time, but I saw a lot of small variations here and there. So what this is a combination of the C and C++ keywords. Lots of times most books are written as C and C++. I have one book where they broke it up. First they showed the C keywords, and then next page they showed the C++ keywords. So then I found another book, and they just displayed it like this. For the most part, you don't really have to worry about these much. As we go through the videos, we'll learn these. Like a few we've bumped into our class. Where's int? Here's int. Float we've done. And so on. But what I discovered is they're coming out with new ones. So here's some of the newer ones in C++ 11. This is something new that has come out recently. But these are really advanced topics. These are for transactions. Transactions like for databases, if you swipe your card somewhere, you're doing a database transaction with your credit card system. But these are really advanced things here. Here's some cool links. C++ 11. When I learned C++, I had no idea that there was even versions. So you can see this one came out August 2014. And this page goes on forever and ever. What you'll find is lots of the C++ books are really written for non-humans. It's really hard to understand. Here's another one. Here's C++ 17. It's not coming out for a while. Let's see, 2017. I just brought this up because if you're going out buying C++ books, you might want to stick with somewhat current books, if they're changing things. But the old C++ books will still be great. If you can get them for a penny on Amazon, buy them up. Okay, and then this one here, This is the creator of C++, Barn, and I'm not sure how to pronounce that as Stostrup. This is his page for C++. And he's got some tutorials here. He also writes books on this stuff. So let's see. Let's see if we can find the book here. This is the book. I guess this is the newest one, 4th edition, C++. Let's see what this is going for on Amazon. Okay, so a used one's $48, a new one is $55. So that's getting up there. Here's 39. Here's an older one for a penny. Can't beat it for a penny, right? Used one for a penny. $3.99 to ship. So these books are really hard, so at this point I wouldn't worry about it, but I just wanted to point out his website and his book, just so you're aware of it. So I like these. I have a lot of C++ books, but these, if I was to recommend one book, I'd start here. And there's older ones. Here's the one that I usually start with. You know, of course I have more that I flipped through. The C++ Complete Reference. This is the 2nd edition. Okay, so that's this one here. It's the same as the bigger one, you know, the newer one, but it's not as thick. It's more concise and to the point. Where the newer one, you know, it's like this thick, and there's a bunch of stuff in there that you won't need for years. So this is usually my go-to book, the one I start with. The reason why I say that is because the examples are clear. You know, they make sense. You know, there's a lot of other C++ books I like, but sometimes the examples are kind of tough. It takes a while to decipher what they're trying to show you, where this one is good. Okay, so see ya. Bye.